For everybody here, just this is a monthly webinar series that we're doing. Today's topic is going to be on cabinet isolation on RC walls, cabinets, and other heavy objects like TVs, headboards, those kinds of things. We have a webinar. We're doing these regularly. It's the fourth Thursday of every month. So we'll post our next one soon. We've actually got a link at the end of this presentation where you can go to register for the next one, and that will be on our RC1 Boost, and it's used to improve the performance of Resilient Channel. And stay tuned for additional ones. We're trying to do more of these just to put out more information about our products and to help people with solving acoustical issues in construction. So I'll wait just another minute or two and then go ahead and get started with the actual presentation. But I'll go ahead and introduce myself. I am Mike Raley. I am PAC International's Acoustical Engineer. Started with PAC January of this year. Prior to that, I worked for another manufacturer in acoustical products, and then prior to that, worked for as an acoustical consultant for 10 years here in the Portland area. So I come to a lot of this with still the perspective of an acoustical consultant, and try and provide the sort of information that I wanted as an acoustical consultant, and that the architects and folks that I worked with often wanted, and try and address some of the issues that I saw a lot as a consultant, which is what this presentation goes into a lot. So I think I'll wait just one more minute or so and then go ahead and get started. And just an FYI, for those of you that have just joined us, the presentation is being recorded so that we can post it on our website and YouTube channel later for other folks to go watch if they weren't able to see it or participate. All right, at this point, I think I'll go ahead and get started. So yeah, thanks for joining us. We appreciate you taking the time to join us for this. Today we're going to talk about the PAC-RCB. It's a new product that we've been developing to really solve like a long-standing acoustical issue in construction. Like I said, one that I ran into a lot as an acoustical consultant, and it is how to handle cabinets and other heavy loads like TVs, headboards, nightstands, grab bars, all those kinds of things on walls that have resilient channel. How do you support those things, provide the structural support for those heavy loads, and still provide the acoustic isolation of the resilient channel? So that's what we're going to go into today. So here's a perfect example of what I often saw as an acoustical consultant out in the field. So is this okay? You've got your resilient channel, and they've got Clark Dietrich RC Deluxe, right? The industry standard here. But you've got these OSB panels in here, and that's not okay. And as an acoustical consultant, we always knew that wasn't okay, figured that it would degrade the performance. But now we've gone and we've done testing, PAC has done testing and shown that, yes, it does degrade the performance, and it gets you to the point where that wall no longer meets the code minimum of STC 50. So that's what we're going to get into, that issue, some more details on it, and how PAC can fix it. So the problem here is on walls, a single stud wall with resilient channel, contractors will often place OSB or plywood between the resilient channels or in place of the resilient channels, as you see on this wall, to provide a rigid mounting surface for cabinets and other heavy loads. Right, and there's a couple reasons for that. One, they want a large area to screw into that's solid, that's going to be able to hold those heavy loads. But also, when you put the resilient channel there, there's this gap between the gypsum board and the structure, whether it's wood studs or it's steel studs. So you got to make up that space so you don't just crush the RC and the gypsum board into that structure. But of course, then this creates a short circuit. And here it is on steel studs, right? The same thing. This looks all nice and neat and pretty, but they've completely short-circuited the resilient channel here, right? Because the resilient channel is there to structurally isolate the gypsum board from the studs so that you don't get sound transmission through. So this is the idea, right? You've got your studs, you've got the resilient channel on the right-hand side, the big green arrow, teal arrow, you've got your sound, your incident sound hitting that wall, right? And that resilient channel acts sort of as this little metal leaf spring that isolates that gypsum board from the structure. So less of that vibration energy actually makes it into the studs and then out to the other side of the wall. But when you put cabinets and OSB or plywood blocking in there, you create this rigid path. So you've eliminated the isolation or significantly reduced the isolation provided by the resilient channel. And then we call that a short circuit, right? So what happens when you do that? So the base wall here in our testing is it's a 2x4 wood stud wall, 6 inches on center. You know, I think it was R13 bad insulation in the cavity, 2 layers of 5/8 gypsum board on one side, 1 layer on the RC side, and RC Deluxe. So pretty standard wall, and standard, you know, built right, this is SDC 54, comfortably above the code minimum of SDC 50 for, you know, multifamily construction. But when you mount cabinets on it using the typical method that we saw those pictures of with plywood or OSB backing, takes the rating of that wall down to an SDC 46, which is well below the code minimum of SDC 50. So you have a wall that no longer meets the building code. And an 8-point reduction in your SDC value, right, from 54 to 46. 10 dB is like a doubling or a halving of loudness, depending on which way you go, right? So an 8-point SDC reduction means the sound on the other side of the wall, the receiving side of the wall, is almost twice as loud with an SDC 46 as it is with an SDC 54. There's some gross approximations in that, but it's way louder on the other side of the wall, right? So it becomes an issue. For the acoustical engineers on here who want to get a little bit more into the data, right? Here's the 3rd octave band data. And so for those of you who aren't used to looking at these graphs, it can be a little bit confusing. On the x-axis here, the horizontal axis, we have frequency. And going from low frequencies, this is sort of like subwoofer level, up to very high frequencies. Speech range is sort of right around in here, generally speaking. So this on the y-axis or the vertical axis, we have the transmission loss. So how much noise reduction we get from one side of the wall to the other. So higher values here are better. So we can see that the blue line, right, this is the base wall. This is the SDC 54. And this is a pretty typical curve for a, you know, single stud wall with resilient channel. The red line is the wall when we mounted the cabinets using plywood backing or OSB backing in between the resilient channel. So you can see that there are reductions at most frequencies. And at this range, which is a lot of sort of the critical speech frequencies, we see more than 10 dB reductions. So you see significant reductions in the amount of sound isolation and the noise reduction provided by this wall. So current solutions, right? How are we addressing this today? There's a number of different ways that people will address it. So one is just don't put the cabinets on the RC side of the wall, right? It seems simple enough, but there's a lot of instances where you just can't do that. You've got back-to-back kitchens, something that I ran into a lot. So cabinets are going to have to go on both sides of the wall. One of those is going to be the RC side. Maybe you have other things like you've got stairs or an elevator on one side of that wall. The other side is a kitchen or something like that that's going to have cabinets, and you can't change which side the resilient channel is on. So there's a lot of reasons that, you know, restrict where you can put the RC in the cabinets, and they wind up having to go on the same side of the wall. Other options are staggered and double studs, and those can work well acoustically, but they take up more lumber, there's more labor, and they take up more space. And so a lot of times for space or budgetary reasons, builders, developers don't want to do those. And so, you know, usually if you're considering resilient channel on a project, it's because they don't want to pay for staggered or double studs. So another option that's been around for a while is another PAC product, right? It's the RISC-1 backer. But it's really intended to work with the RSIC 1, right? So the geometry of it, the thickness of it, the way it installs, all of that is designed to complement the RSIC 1. So if you have a wall where you're using the RSIC 1 clip, the acoustic isolator on one side of the wall, and you need to support heavy loads like cabinets, you can use the RSIC 1 backer to provide an isolated backing to screw those loads into. So it works well there, but it wasn't really intended to work with resilient channel. Through adding additional blocking to change the depth and the offset, you can make it work, but that's just not what it was optimized for. So what PAC has come up with is another isolated backing system for cabinets and other heavy loads that's designed specifically to work with resilient channel, which is common on a lot of multifamily and hotel construction and other situations as well. And so we've gone in and we've done acoustical testing to validate a prototype of this. And so we found that when we went in, we tested our base wall, right? Then we installed cabinets the normal way, what we often see. We reduced the STC to 46 below minimum code. But when we came back in and instead used the PAC-RCB, the resilient channel backer, to mount the cabinets, we were able to maintain the STC rating of that wall at STC 54. So we've got cabinets that are mounted in a way that can carry that load, but we can still maintain the original acoustical performance of that wall. So just an overview of it, right? It's easy to install. It's just a couple of screws. We have some install tools for it and things like that as well. We have standard and heavy duty versions designed for different load carrying capacities. It's adjustable for various stud spacings, right? So I have here sitting next to me so you can, there's some slots, which I can actually show better here. There's slots in this, right? So there's some movement so that you can adjust it, get some fine kind of adjustment once you sort of mount the brackets to the studs. But also you just use a 2x6 in wood frame construction to span between the isolators. So just cut your 2x6 to a different length and you can accommodate different stud bay widths, whether it's 16 or 24 inches on center or 12 or something weird because of just where it lines up in the wall. It's compatible with wood and steel studs, so you can use this in either type of construction. It uses readily available materials for blocking, right? For wood studs, it's just 2x6, right? Readily available on the job site already. And for steel studs, you would just use, create basically a box beam out of steel track, and then an actual stud that then get mounted the same way that this 2x6 is. It'll come in a kit that includes the screws, the isolators, and the metal bracket. So all the mounting hardware and everything like that that you need are there. The only thing that would be supplied by others is the actual blocking itself, the 2x6 or the track and steel studs. But those things are already going to be on the job site anyways. And then we also have an install tool available for consistent isolator preload. So we have these cool things. This is just a prototype that we've 3D printed. But the idea of this is this acts as a depth stop so that you don't overcompress or undercompress the rubber. So it's not loose where things rattle, but it's not, they don't just yard on it so that it's so tight that you've completely squeezed the rubber to make sure that it functions well. So we have that, and it's available for a bunch of different tips for drywall screw guns as well. Applications, cabinets is what we've tested it with, where we've actually gone and done testing in the lab, mounting cabinets onto the wall. But it would work with headboards. A lot of times in hotels, the headboards are mounted to the walls, right? That's this big surface and sometimes could be heavy too. So work for that. Televisions, speakers, nightstands, shelving, closet organization, grab bars and handrails. That's a major consideration in senior care facilities, those kinds of things, right? Where you need to have those grab bars, but you also want acoustic isolation between the corridor and the living spaces. So a lot of different things that you can isolate with this, use this for, and we have already done structural testing to see the load capacities, and we've got plenty of margin of safety here, so we can certainly carry these loads and things. And you can. That's why we also have the standard and the heavy duty versions and those things. So the installation is pretty simple. You have this bracket that gets screwed onto the studs, and then you just screw in the blocking from the back if you've got access to the back, or you can prefabricate it with the isolators on the blocking and then go and just screw that into the face of the studs. And then that's why we've got that adjustability in there, so you can make sure that you've got space, that it fits and it spans that distance. So you don't have to get your cuts exact to make it all line up. Here it is, those drawings for steel studs. So you can see in the middle here how we've got the track and the stud sort of nested together to make this box beam, that they get screwed together and then screwed in from the back, just like the wood 2x6 does. So the acoustical performance of this, right? So again, the STC rating with the backer is STC 54, so the same STC rating as the base wall, with just the RC channel, no cabinets, nothing mounted on it, right? Just a pristine wall. So we maintain the overall STC rating of the wall. Again, for those of you that want to get into the nitty-gritty details of this, here's the third octave band TL data. Again, frequency on the horizontal axis, transmission loss on the vertical axis. So the blue again here is the base wall, and the red is the wall with the cabinets mounted with plywood or OSB. So again, we see those significant reductions here, and you can see the delta values down here. And then the green is with the cabinets mounted using the PAC-RCB. So we see actually that at low frequencies and at high frequencies, this is the coincidence dip of the gypsum board, right? So from here up, we actually see improvements in the transmission loss with the RCB and the cabinets. In the mid frequencies, we do see a little bit of reduction in the TLs, but it's pretty minimal. I mean, for the most part, it's 1 or 2 dB. So, pretty minimal losses and some improvements at actually the areas that have the most deficiencies, which I think is pretty interesting. So that's it for this one. Our next webinar, as I mentioned, is going to be the RC1 Boost. And so check that out. Here's a little URL where you can register for it.